same way like لو انا برضه vector value function لو انا واخد h is greater than 0 this is rt plus h minus r at t واخد h less than 0 that's gonna be the case in both of them r dash represent the tangent. Are you with me? Okay, really very good. Let's see some problems from sheet 3. Sheet 3 is massive. Sheet 3 contains a lot of problems, okay? And also we will go through 4 and 5 today. We have plenty of applications or exercises we will have to go through today. The problems in the sheet are really very important because they are really very close to the problems that you will see down the road in your exam. So let's see for this one, he's asking you, list number 4, curves and vector functions represent geometrically the following parametric curves in R2 and determine the velocity and acceleration vectors at each point. In most of these problems, I will consider t, my new variable, as the time. So, which means the function that I will give you represent a distance. So if you have a derivative, the first derivative will give you the velocity. The second will give you the acceleration. This is why in most of these problems, when he asks you about the velocity, he means the first derivative. Acceleration, it means the second derivative, as you know, Mr. Faisal. So if I look to the first problem, the following parametric curves and determine the velocity and acceleration. It's xy, where the x, the function in the x direction is 2t plus 1. The function in the y direction is t squared. So simply I can write that r vector for the first function is simply 2t plus 1 in the direction of I plus t squared in the direction of j. معايا Miss Nada? Okay, get the velocity please. How to get the velocity? Okay, I will get r dash. So I will differentiate this guy. So it's going to be 2 over I plus 2t times j. معايا يا شباب؟ طيب, how to get the acceleration? It will be the second derivative of this value. So simply, if I want to get r double dash, it's really very simple. So this component will be 0, and you will have 2 in the direction of j, as you can see. So that's the derivative of the vector valued function. I'm differentiating each of the components, as you can see. So once more, by the idea, the first shape, which is 2t plus 1, and the t squared, it will represent a parabola. Okay? It will represent a parabola. As I explained at the beginning of this lecture, just substituting with the values of t, you will have the points near each other. So if I'm using, for example, if I'm using t equal to 0, how it's gonna be, Ms. Soraya? Let's substitute in this equation by t equal to 0. How it's gonna be? 2 times 0, 0, plus 1. So the first coordinate is 1. Substitute with t equal to 0, which is 0. So actually, if I'm trying to graph this function, I will start with the point 1 and 0. So this point. Take t equal to 1 and start substituting. So you will have your x and y coordinates, okay, corresponding to t equal to 1. So in a similar manner, you will have 3 and 1. So the second point will be x at 3 and y at 1, this point. If I'm using t equal to -1, I will have the corresponding point in the other direction, and so on. If you gathered these points from negative infinity to positive infinity, you will end up having this shape. Okay? Which is a shape of a parabola. If you remark, that's the vertex which is at 1 and 0, as we saw just in seconds when we make a substitution. Now I have the shape of this parabola, which is represented by a multivariable function, but in just only one variable, which is t. طيب, r of t is really very simple, which is 2ti plus t squared j If I want to get the velocity, just differentiate, that's the function. If I want to get r double dash, which is the acceleration, do the second derivative. معايا مستر فيه؟ طيب for problem number B, that's cosine sine t and cosine t minus 3. Cosine t minus 3, it's an equation, it will represent a circle. So for the second parametric Meseda, it's going to represent a circle. But this circle, okay, not with a center at 0, 0. The center will be in x direction at 0, but in the y direction at negative 3. That's the shape of the circle that we are talking about. That's the radius, that's the center, which is 0 and negative 3. And the radius, since this value here is positive 1 and that value is positive 1, is equal to the radius, which is equal to 1 unit. This is why the maximum is negative 2 and the minimum is negative 4 in the y direction. So that's the representation of the second relation. Of course, let's say that I can get r, which is sine t in the direction of I and cosine t minus 3 in the direction of j. If I want to get the velocity, I will have to differentiate once. If I want to get the acceleration, I will have to differentiate twice. So, okay, once more, this is r dash and that's r double dash, and for the angles from 0 to 2 bar. At the time being, just I want you to relax about the shapes. You will be able to recognize most of them, but within the second session, within the second PDF that I will talk about. Okay? Go through this one also. This is more problems handling the part that we are in. He's giving you geometrically the following parametric curves in R3 and determine the velocity and the acceleration. The first one, which is 2 sine t, 4 cosine t, but t equal to 1. Can you speculate the shape? I will leave Nada, she didn't attend from the beginning. But Mr. Ziad, please look closely to the expression given. 2 sine t, 4 cosine t, and the t is equal to 1. T is equal to 1 means the z, not equal to 0, not in by 1, but in the plan where all the points will have a z value equal to 1. So if I concentrate with these two guys, it will give you an ellipse. This is sine t and cosine t. The radiuses are different. This is 2 and that's 4. So it will give you an ellipse. So if I try to give you the sketch of the first one, this is hopefully, I think I've drawn it. Yes, here it is. That's the ellipse. It is an ellipse, but in corresponding to the plan where z is equal to cam to 1. Are you with me? ماشي. طيب, if I want to get the velocity, it's very, very simple. This is the position vector, r, 2 sine t, 4 cosine t, and of course, this is k, the value of t is equal to 1. Get the first derivative, this slide, which means it's going to be 2 cosine t, negative 4 cosine t, and this is going to be 0. Okay, get the acceleration, start differentiating for the second component, that's going to be the shape. Mr. Faisal, can you speculate the shape of this guy? This is cosine t, sine t. But remark, for the value of t, it's moving, it's raising. If I eliminate this guy, you will have cosine t, sine t. Yes, you are right, it's a circle. A unit circle, since this number is positive 1. So it's a unit circle. But this unit circle, with each value of t, the z will be raised with the same value. You understand what I'm saying? If I'm using t equal to 0, you will have the first point in by 1. If t equal to 1, you will have the second point on the circle, but will be raised from by 1 by the value of by over 2. If I'm using t equal to 2, I will have another point on the circle, but not with the same level, with a raising level. So it's gonna be a spiral. That's the shape of the second function. That's the shape of this guy. Of course, if I want to get r dash and the r double dash, it's gonna be exactly the same. Differentiating the components, it's an easy task. This is for r dash and that's for r double dash, but that's the shape. Remark the spiral shape. The spiral shape because it's a circle, but I've actually raised the points of this circle. معايا مس فيصل؟ معايا مستر زياد؟ Okay. طبعا I'm talking about Mr. Faisal and Mr. Ziyad لأنهم they attending from the beginning. Yeah. ماشي؟ Okay, let's look to this one too. He is asking you to compute the velocity and acceleration vectors of for all t and define the equation of the tangent line. Okay, let's find the equation of the tangent line. I've already spoke about the tangent line previously. Any tangent line can be represented easily by a point and the direction ratio or a vector. By a point and a vector. Okay, this is the parametric representation of any straight line. So any straight line, let's say n, it's gonna be a point plus some variable, some constant, you will have to choose it, times the vector, which is the direction ratio. We already know from the previous slides that the first derivative is the vector direction of the tangent. So all I have to do, if I want to get an equation of a tangent line, and that's a repeated question in exams, I will have to get the point, which is from R. I will have to get the first derivative, which is the vector, okay? And then substitute in this equation. So let's try to do this with those problems. I will start with this guy. Now I can get R of t. What's R of t, Farid? R of t as a vector is gonna equal to sine 3t in the direction of I plus
cosine
3t in the direction of j plus 2t to the power of 3 over 2 in the direction of
k.
Very good. Okay, at t equal to 1, it will give you the point. So at t equal to 1, it will give you the point. So all I have to do is to make a substitution at t is equal to 1, which is gonna be the point. At t equal to 1. Make the substitution, you will have the 3 component. This is gonna be a sine over 3, then a cosine over 3, then it's gonna be 2. That's the point. I need the vector. In order to get the vector Faisal, I will have to differentiate. Start differentiating. So r dash t, it's gonna be 3 cosine 3t. Do you have problem or problems in differentiation? Miss Nada, can you differentiate cosine 3t for me? Differentiate cosine.
Negative sign?
Yes, negative sine 3t times 3. Am I right? Then in the direction of j, plus differentiate this one, it's gonna be 2 times 3 over 2 times t to the power of half. Am I right? This is k. I need the vector. So all I have to do is to make substitution instead of t by 1. Now I have the vector. Then I will be able to write the equation of the line. The point plus lambda times the vector.
احنا ما فيش كالكوليتر.
طبعا.
احنا المفروض بقى نحسب الحاجات دي.
هو انت حسبت ايه اصلا؟ بتسيبهم زي ما هم عملوا لك حاجه؟
احسبهم زي ما
مضايقينك يعني؟
هو بصراحه
لا طب
ده بيفضل الايكويشن يعني
مش ايكويشن، بتفضل الفاليو. هو كوزين 3 خلاص. انت راجل دلوقتي كبرت. طلع شهر. ما انتش محتاج تطلع كوزين 3 بنمبرز. هي كوزين 3 خلاص احنا كلنا عارفين انها نمبر، صح ولا ايه؟ اوكي شباب وانس مور بصوا طبعا معلش ثانيه واحده. مهم قوي انك تحل كتير. It's really very important to solve as much as possible. Because since I have solved or discussed 2 or 3 problems of the spiral case, now I'm really very comfortable when I see this equation. It's gonna be a circle, but since t exists here, it will be some kind of a spiral. صح? Because I saw it, this is the 3rd time.
Oh, doctor, why do we need to know the shape? Are they going to ask us to draw?
Down the road, you will need to imagine what does it stand for. So by trying the problems step by step, and within the second slides that I will go through, you will feel really very comfortable around the parametric representation of curves and everything. Okay. So once more, that's the shape, which makes sense. Okay. This is R, that's R dash. صح؟ معايا يا شباب في صح؟ Okay, second step, this is R double dash. He asked for the acceleration. I'm not going to use it, but anyhow, it's just very simple. I will have to differentiate R dash once more, so getting these components. In the exam, it will be usually multiple choice. So he can give you the function and ask you about the velocity to choose one of the correct answers. Or ask you about the tangent plane, as you would see. So next step, this is going to be at t equal to 1, I will need the point and the direction ratio. The point, simply I will substitute in here by 1. The direction ratio, I will substitute in R dash by the value. So once more, that's the point at t equal to 1, and that's the vector at t is equal to 1. All I have to do is to put them together. The point plus lambda times the vector. So I will take these three values plus lambda times these three values. This is what you are going to see. So x, y, and z will equal to. Those are the coordinates of the point. This is lambda. Those are the coordinates of the vector. معايا Mr. Ziad? The second step, get the I values together, the J values together, the K values together, which is standard for X, Y, and Z. That's the second step. This is for X, that's for Y, that's for Z. Now I have the parametric representation of the line that will be a tangent to this curve. Can we do it once more? Ms. Nada, can we do all the steps once more? Yes. But I will do it with which one? With this problem. I will do exactly the same. I will start evaluating R, which is going to be the three components. Then I will differentiate R dash. Then I will substitute by t equal to 0. Then I will put them all together. That's the second problem. This is really, as I told you, very important, and you will see it in more problems down the road. So if I'm using t equal to 0, it also will be a spiral. This is the three components of R. This is R dash, which is the vector. That's the acceleration. This is how to write the tangent line at t equal to 0. So all I have to substitute for the point, substituting t equal to 0, all of them will be zeros, which is the origin. Get the direction ratio, which is 0, 1 under root 3. Just to make the substitution exactly the same. Once more, those are the coordinates of the point, and those are the coordinates of the vector. Those are this guy. And that's the coordinates of the point. That's the coordinates of the point. معايا؟ خلاص, it's done. I can get the value exactly as you can see. في الامتحان يجي يقول لك the equation of the tangent line to blah 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 is 1, 2, 3, 4, and 5. This is one of them. So you will choose the correct answer. صح؟
Doctor, when you substitute to get the direction, the dr, is it after substituting the t or
Yes.
before?
Yes. After substituting by the value of t. If I'm talking about the general equation of the tangent, regardless on the value of t, you will put them all together. And it will be a function in t. ماشي? Okay, thank you very much for this guy. The slides that I was waiting for to go through it are those ones. This is actually all the previous slides that we went through. It's still 10:30. You will have your break at 11, okay, 11:15, 11:19, 11:30. Okay, you will have a half an hour or so, okay, or half an hour is so much, 10 minutes. Then we will go there. Okay.
طب ما تيجي نمسك العصا من النص يا دكتور.
ما ينفعش لان امتحانك مش الاربع ده، الاربع اللي بعده.
ما انا عارف، ما انا عارف. شكرا. بجد. تقدرش؟ وقبلها بيوم عندنا ايكونومكس.
ما هو حضرتك ما تستناش يبقى البقعة على راس
دول
الإيد.
ساعات.
لا احنا مش
Don't
مستني،
wait here.
انا مش مستني، انا بقول له بس بعرفه.
ماشي. خلاص. Don't worry. It's an extension to what we have been going through. So if you look to this problem, okay, طبعا هنا do you remember انا كنت بس بفكر your previous colleagues بس احنا بالنسبه لنا we are خلاص احنا we already remember يعني. هنا بيقول لك determine the vector equation of the tangent line. يعني انا بسألك على equation of tangent line. Can you remember what is the equation of tangent line? Get the point, get the direction ratio, put them both together with lambda. صح? Remaining, what is the function? The function is given by x equal to theta minus theta, y is equal to 1 minus cosine theta. And I want you to evaluate this tangency at t equal to pi over 4. Let's redo all the steps. I will start by getting the r. So actually this is the shape of this function. If you try to use the substitution for plenty of t, this is going to be the shape. Okay? طيب, let's start. This is r, which is theta minus sine theta I, 1 minus cosine theta j. I will get r dash, which is the vector. صح? So start differentiating, which is going to be 1 minus cosine theta. And for this one, it's going to be positive sine theta. Please do review your derivatives, or the derivatives of the most common functions. So this is r dash, I can get r dash as I told you. This is r dash, 1 cosine theta I plus sine theta. Since he wants me to get the tangent at theta equal to pi over 4 with theta, I've replaced these values by pi over 4. Okay? I don't need a calculator for pi over 4 because pi over 4 is 45. So cosine 45 is how much?
Half.
1 over root 2. 1 over root 2. صح؟ طيب, with sine same way like. So I make the substitutions, as you can see, pi over 4 minus 1 over root 2 and so on. Okay. Now r dash, I will use replacing the theta by also pi over 4, so this is the value. That's the point, and that's r dash. Now I can write the equation of the tangent plan, which is going to be the equation, the point, lambda direction, the point, which is those guys, I and j, the direction issue, which is these 2 points, or these 2 values. That's the point, that's the direction issue times lambda. I think it's very, very simple problem. It's 1, 2, 3. Getting the r, step 2, get r dash, use the equation point plus lambda r dash. Okay? Okay, bravo. Very good, that's the shape of your function. He is talking to you about the tangent vector in parametric representation already knew. That's we will get r dash, so it's okay. A vector function, what's the C1? The C1, it means the functions that is differentiable for has the first derivative. For C2 functions who has second derivative. For C3 functions who have the third derivative, and so on. So it is continuous till the third derivative. So a vector function is said to be regular in I if R belongs to C1, where R dash T node is not equal to 0 for every T belongs to R. The regular curves, let's see a curve or line oriented in space or in the plan. So either your curve in space or in plan, we call regular curve if that's the condition. C is a closed curve. But not all curves are regular curves. The regular curves are the closed ones. But what's the sign of the closed ones? It's said that C is a simple curve if it has a single point of overlapping. The end point in the beginning of point. So it is the first point and the end point. And they are overlapping each other. So it's going to be like a circle or like a closed line. This is what's called a regular curve. Something like those guys. See? Those curves represent a closed or regular curves. Also for this one, C1, C2, C3, and C4. The beginning is overlapping with the end point of your curve. C is not a closed curve when there is no overlap of your curves. يعني يبقى الشيب زي ما انت شايف. هذا C1, C2, C3, C4, but the beginning is not the end of your curve. The definitions are important because we will see them down the road. Okay, C is a regular curve if it is simple curve and there exists a regular vector function whose graph is C. That's the condition for regular vector, regular vector functions. Sectionally regular curves are those curves which is not closed, but it consists of some of the curves. As you can see, this is C1, C2, C3, and C4. We will go to the direction, but down the road. Parametrization of curves in the plane or in space. طبعا ده انا عديت بيه قبل كده. We already did go through this. R of t represented the shape, so it will instead of dealing with x, y, and z, I will be dealing with functions. F of t x, g of t y, h of t is z. That's the shape of the function, can be also written in this manner. And this is x, y, and z exactly as I told you. That's for this slide. To convert a Cartesian equation into the parametric form, we will have to follow some steps. The steps are very, very simple. ما تفصلش. الجزء ده مهم قوي. Okay. Different curves have different natural parameterization. The approach depends on whether the equation represents a line, circle, ellipse, parabola, or any other shape. This part will make you perfect the shapes and the equations of any parametric shape. Okay? It's well written, so it will make your life really easier. So identify the type of your curve, introduce a parameter, use t or theta. This is if you like to move from Cartesian to parametric. So if you take the decision to use parametric representation, I will follow these steps. And also solai, I will use these steps if I don't know the parametric representation of the curve that I'm transferring. But with the coming slides, you will have the knowledge and experience to look to the curve or the famous equation and to find its corresponding parametric equation. Okay? So first of all, identify the type, introduce the parameter, then make the substitution. This part is really very important. I'm going to talk about the famous shapes and the equations, okay, and its parametric representation. The first famous shape is this shape of a circle, which is x squared plus y squared equal r squared. معايا زياد؟ طيب لو أنا عندي x squared y squared equal r squared, what's the parametric representation? X equal to r cosine t, y equal to r sine t. So the parametric representation is done now. Any circle whatsoever, you can get its parametric representation. So if I have a circle, x squared plus y squared equal to 16, what's the parametric representation? 4 cosine t, 4 sine t. Okay? It's really very simple. So as you can see, I will take the square root of the radius, and it's gonna be r cosine c, r sine c. Like, what if the function, what if the circle بسندة is not at 0, 0? What if the circle is not, if the center is not at the origin? All you have to do, Farid, is to add the coordinates of the center in front of x and y. So what I mean, if you have the shape of a circle, this circle, which is x minus h to the power of 2, y minus k to the power of 2. That's a circle with radius r. But the center is at h and the k. So the parametric representation, boss, the parametric representation, x will equal to h plus r cosine t. That's the shape of your, or that's the form of x. X is equal to h, because it's in the x direction, plus r cosine theta. Y will be the same. So it is khalas, like Dr. Francesco said. It's khalas, it's done. Now I know the circle in the, when the center is the origin, or the circle if the center is not the origin. Type, what's the second, the famous shape that we dealt with in the previous slides?
Ellipse.
The ellipse. So the ellipse, the difference will be really minor. The ellipse, all you have to do, what's the difference between a circle and ellipse? The circle, it has just only one radius, but in the ellipse you have two of them, semi-major axis, semi-minor axis. So all I have to do is to, instead of using r, this is going to be a cosine theta, and this is going to be b sine theta. That's the equation of the ellipse. If I have x squared over a squared y squared over b squared, which means this is a and b, so the shape that you are dealing with is a cosine theta, b sine theta. What if the center is not the origin? I will add h in here, I will add k in here. So that's the general case of an ellipse, but the case of the center is not 0 and 0, the center is h and k. So all I have to do is just to use h plus a cosine theta and the k plus b sine theta, as you will see. That's an equation of an ellipse. By the idea, since we are in this place, what's the shape after hyperbola, which is really very close to the equation of an ellipse? And instead of dealing with cosine and sine, please use cosine and sine. Cosine hyper and sine hyper. Instead of dealing with cosine and sine, deal with cosine and sine. Are you with me? Okay. If I'm talking about a second degree parabola, this is also a case that we usually use. In this case, it's really very simple. Both x equal to t and y will equal to t squared. So that's the parametrization of the parabola. Both x is equal to t and y will be equal to t squared. Now what is the case? This parabola is symmetric about the y-axis. If it is symmetric about the x-axis, then exactly do the same. Both y is equal to t and the x will equal to t squared. Are you with me? See that? Okay, that's the shape of your parabola. If I'm talking about a line, y equal mx plus c, which is an equation of a straight line. If I want to represent it parametrically, I can. Both x equal to t and the y will be mt plus c. That's the parametric representation. Now I know the circle, the ellipse, the parabola, straight lines, and that's the stop. بص على الشيب ده. بصوا عليه. مش دي اللي انت كنت بتعملها من شويه صغيرين؟ This is what we were doing previously, that x and y is equal to the point plus some constant, in this case I will call it t, times the direction ratio. Okay? If you make the substitution, point B, which is x1, y1, plus t times a difference between 2 points on the straight line. So it's an x2 minus x1, y2 minus y1. If you look to this representation, that's the representation of the straight line, which is exactly the same. Are you with me? So this is how to represent a straight line in parametric representation, as you can see. Okay. طبعا general strategy for curves involving x square y square, use trigonometric functions. For lines or linear parameterization, حط x equal to t, y will be mt. Parabolas or other polynomials, express one variable in terms of t, يعني make a substitution for one variable bt and get the other as after the substitution. Okay, exactly like this guy. I'm putting x equal to t, so y will equal to t squared. ماشي؟ معايا؟ Okay. That's the shape of that's the parabola when the vertex is not at the origin, and you will have some value. This is the equation of the parabola. Also in the x direction or in the y direction, it's already written. That's the hyperbola equation, as I told you. It's exactly like the ellipse, but instead of having cosine, you are using cosine, and then instead of having sine, you are using sine. And if it is in the other direction, relative to x, you will change them. So x is going to be hv sine t, and y equal to b cosine t. Some problems on this part. If I want to represent this circle, what's going to be? 2 cosine t, 2 sine t, صح? So it's going to be, this is the parametric, it's going to be 2 cosine theta, or 2 cosine t, 2 cosine t, 2 sine t. If you try to move back from parametric into Cartesian, All you have to do is to make the substitution. You will be able to get exactly r squared, which is the equation. That's an equation of a circle. But the center is not the origin. The center is 3 and 2. Can you give me the equation? So x is going to be 3 plus cosine t. No, plus 5 cosine t. 5 is coming from the radius. Can you give me the y coordinate? The y is going to be negative 2, then plus 5 sine t. That's the equation. So it's going to be negative 2 plus 5 sine theta or t, whatever. ماشي? That's an equation of an ellipse. That's an equation of an ellipse. The equation of an ellipse. Because if you divide on 36, this is going to be 9 and that's going to be 4. That's an equation of an ellipse. I can use, of course, an equation of a hyperbola because the sign is negative. So I'm using the cosine and sine, as you can see. So this part just making substitutions, and you will have your center A and B and everything, as you can see. Also, this is a representation, a training on a parabola. خلاص, I will skip this part. I made plenty of problems just to be sure that you are perfect in just translating. It's exactly the same if we are talking in three dimension. But in 3 dimension, since we already talk spherical coordinates, I can add the knowledge of the parametric representation with my experience in the coordinate systems. So one of the really very nice parametric representation in the surfaces is using theta and phi. So in this case, I'm not using just only one variable. I can use how many variables? 2 variables. If you like, okay? I can use how many variables? 2 variables. And in this case, it will be the spherical coordinates. So x is gonna be h plus a cosine theta cosine phi. K will be b cosine theta sine phi. And z will be m plus c sine theta, as you can see. It's a link between the spherical coordinates and the parametrization. That's for ellipsoid, as you can see. Okay, for this guy, it's a direct application. The center is 2, -1, and 3. I have the radiuses, which is 3, 2, and